The seventh poster shows the docked connecting modules of one of the arms of the butterfly ferry centrifuge. They dock along the emergency crossing line position 16. Subsequently, a vertical greenhouse is installed in the connection space. His enlarged footprint is shown at position 18. With its docking fasteners, it further secures the connection of the connecting modules. The traffic path can be tracked using red lines. The outer contours are filled with manually replaceable cylinders of fuel components position 22, for gravity engines position 7, and correction engines position 8. Each of the connecting modules is molded on a 3D printer from low molecular weight polyethylene. Entirely or in segments, followed by welding. Everything is cast at once, stiffening ribs, niches, stairs, cable routes, landing rails, openings, and so on. Of course, in addition to the insulated oxidizer line, which has a jacket with radiator fins in the form of steps of a spiral staircase. Then the casting is covered with the composite material, with strength beads in the places of fastening and holding. The design is very light and durable thanks to the stiffness sets, which are not reflected on the posters. The eighth poster introduces you to the concept design of a solar tandem residential module unit. Like the connecting block, it is molded from low molecular weight polyethylene using a 3D printer. Naturally, HALS is added to polyethylene, an inhibitor, stabilizer of protection against ultraviolet radiation. The best of them is considered to be soot. It doubles the service life of polyethylene when exposed to ultraviolet light. True, then the walls of the rooms will be black. The use of polyethylene is very important and wonderful because we are able to create any shape, and it is the lightest and most flexible material. With its help, we create water pockets in the front of the ship position 7. By filling or draining drinking water from them, we control the gravitational geometry relative to the axis of the ferry. We adjust the thickness of radiation protection in the selected area of the ship, but due to the large coefficient of stretching and thermal expansion, to strengthen the structure, we cover the ship with a composite material, with thickening in places of greatest load, and strengthen the rigidity of the structure with a titanium strip corset position 1. During the casting process on a 3D printer, all the laws of ergonomics and aesthetics can be taken into account. You can paint ceilings, walls and floors according to the purpose of the room during the casting process. For docking, we use my double linear translational I-beam docking unit with force tightening position 3. When docking, the staircase section of the combined block enters the opening of the residential block receiver position 2, floors A, Roman 8, and is hermetically pressed against the entrance hermetic door. This door is crew controlled position 4. The doors to the cockpit are locked by the crew position 5. Floor BB of the Roman 7 is a hygiene room and laundry room. The ferry is designed for 100 passengers. 50 passengers in each arm. Floor NN is technical. Has an N docking unit with a gateway position 2. The gateway operates only near the Earth during the stop of the gravitational centrifuge. Floor CC, EE, D and FF are the floors of passenger cabins having 2 bunk beds and accommodating 4 people in each cabin position 3. Toilets are located along the edges position 4. Floor CC and E differed from floors D and FF by the presence of transition doors position 5, into a shady tandem residential block. On each floor there are crew cabins position 7. The hospital is located on floor GG Roman double, with 2 double rooms. In one of them there are a surgeon and a paramedic. In the operating room position 7, there is an operating table, a chair with an operating lamp, and behind the curtain an examination table position 8. There is also a passage door position 5. All passenger floors are connected by an elevator and a spiral staircase. The habitation module is delivered into orbit by the cargo starship. In the upper right corner, the dimensions of the living block relative to the opening of the Starship cargo hatch are shown. The 9th poster introduces the conceptual design of the Shadow Tandem Housing Module Unit. It is manufactured and delivered into orbit to the ferry identically. The method and nodes for connecting it to the combining block are the same as for the Solar Residential Module. They still have one significant difference. Between them they have an opposite set of docking fasteners, allowing for tandem docking position 5. Let's talk about its characteristic features and purpose. If the Solar Residential Module is a bedroom, then the Shadow Module is a spiritual kitchen training application. Let's start from the top floor. AA Roman 8. It is interfaced with its connecting module. But the docking doors are closed and are spare. They are open when necessary by the crew on duty, mainly to replenish food. Floor BB of the Roman 7 is the kitchen. It contains an induction hob position 2, a microwave hob position 3, and a large dishwasher position 5. Radio cabinets and refrigerators position 1, radio table position 6. The table is very wide and the front edge of the tabletop is on the same vertical with the cabinets, which are mounted above the table and fall on the conical part of the module wall, and naturally the rear wall describes a smaller radius. Floor CC of the Roman 6 is a dining room with 25 seats. Passengers are served in 2 steps. The crew eat separately. The dining room is connected to the solar module by a sealed door. Floors D and the ER gyms with various equipment and exercise equipment position 4. Floor GF Roman 2-3 is an auditorium or assembly hall with 52 seats. And the technical floor NN is a Roman unit, has an N docking unit position 1 with a gateway position 2. The gateway operates only near the Earth during the stop of the gravitational centrifuge. On the 10th poster we will look at the construction and joining of a vertical greenhouse with a diameter of 3 meters and a height of 18 meters. The greenhouse I developed differs sharply from all traditional ones. It is based on spiral shelf hydroponics position 16. Water, air from the living area saturated with carbon dioxide and power supply is supplied through a detachable connector position 15, into the columns for saturation with salts and minerals and automatic process control position 2. Then, by feeders located in the inner edge of the spiral staircase position 19, it is fed and distributed over all shelves of the spiral. White LED lighting is built into the transparent railings of the spiral staircase and, together with the carbon dioxide of the supplied air, ensures photosynthesis. A column of plants with a radius of 75 centimeters is easily serviced from a ladder. Air enriched with oxygen falls down through an open passage position 11. The greenhouse is delivered to the station by cargo Starship and docked with the Canadarm or its equivalent. The docking pins position 13, and the docking unit position 11 of the greenhouse, entering their seats, are tightened and secured. In addition, the ferry is anchored by the ledges of the hemispheres of the connecting block with locks position 3. Then the astronauts brace the greenhouse loops position 21 with braces to the trusses of the rotation arms. In addition to the greenhouse, the 10th poster shows the astronauts' entry path from the elevator shafts, along flights of stairs and docking connectors into the dock tandem accommodation units. The 11th poster shows the conceptual diagram and layout of the modernized Super Heavy system position 1, in connection with the replacement of Starship with a non-returnable booster. Actually, the carrier itself already uses hot start, and I developed my system 2 years ago. The only slight difference is in the design of the stage separation compartment. Must cut rectangular slits around the entire circumference of the carrier, but I used a stocking pattern position 3. Similar to the separation pattern of the Royal N1 rocket. And it seems to me that the open work of the stocking pattern will not have such an effect on the heating of the upper hemisphere of the Super Heavy barrel. Of course, the main difference between the system is the loadless media outputs. Essentially this is a Starship without a payload zone position too. In addition, it does not have Raptor takeoff and landing propulsion engines. Instead, a fourth Raptor vacuum engine is installed. Its other features, the ability to maneuver in orbit, the presence of a pair of universal filling necks symmetrically located on both sides positions 5 and 6. And in the upper, conical part of the narrowing the presence of a heavy load position 15, under the cylindrical fairing position 4. The load is a complete set of originally deployable solar panels on one arm of a gravitational centrifuge. After undocking, the booster and open sets of solar panels each arrive at their own point and, with the help of a canadarm, or a similar manipulator, are installed in their places. The docking area of the new booster is vacated by the standard crossbow launch booster and is placed into the cargo Starship, which delivered the residential module of the tandem arm of a butterfly ferry into orbit. The same thing happens with equipping the second crossbow in the gravity centrifuge arm of the butterfly ferry. And the second regular booster of the second crossbow is picked up by the second Starship, which previously delivered the second residential module.